Okay, so in part three of this lesson, we're going to be multiplying square roots. Now, basically, we've been using the distributive property or FOIL. Okay, so let's look at this example. We either say simplify or it could say multiply. Regardless, you're going to simplify eventually. So number one, you have the square root of 7 times the square root of 5 plus the square root of 3. Okay, now let's kind of review something. So remember a while ago we talked about that if you had the square root of 3 plus 6 square root of 3, that is, and remember you're adding or subtracting, so this is 1 square root of 3 plus 6 square root of 3. Those are like terms. Remember, these are like terms. Um, and in order for them to be like terms and combine them, the index have to be the same, and the radicands have to be the same. So 1 square root of 3 plus 6 square root of 3 is 7 square root of 3. Now, when you're talking about multiplying them, let's suppose you had, let's say, the square root of 2 plus 7 square root of 3, let's say. Now, those are not like terms, so I can't simplify with regards to adding. Okay? Now, what if I were multiplying them? So let's talk about that. So let's suppose I had square root of 2 times the square root of 3. Okay, now I have a product of two radicals. Now notice that the indexes are the same. The indices are the same. They're both square roots, so they're both 2's. Okay, so this is square root, this is square root, so they're both 2's. So all I need to do to multiply them, as long as the indexes are the same, the indices are the same, I can write this as one product, and I would just multiply the radicands together. So 2 times 3 is 6. I get the square root of 6. Okay? So over here, if I wanted to multiply instead of add, I'd had square root of 2 times 7 square root of 3. And so I can multiply the square roots together. So that will be 7 square root of 2 times 3. And you could skip that step and just say 2 times 3 is 6. So you get 7 square root of 6. Okay? So when multiplying radicals, as long as the indexes are the same, you can write it as one radical. Just multiply the radicands together. Okay. All right. So now we have a binomial times a monomial. So I'm going to distribute. So I have the square root of 7 times the square root of 5 plus the square root of 7 times the square root of 3. Now, based on what we just talked about, that right here is going to be the square root of 35 plus, and then that's going to be the square root of 21. And besides 1, there's no perfect square that goes into 35. And there's besides 1, there's no perfect square that goes into 21. And those are not like terms, so there's our answer. You cannot combine them. Number 2, you have the square root of 5 minus the square root of 2 squared. Now remember, this time you have a binomial that's being squared. So remember what that means. That means the square root of 5 minus the square root of 2 times itself. Now, since I have the product of two binomials, I'm going to go ahead and use the FOIL method to make things a little bit easier for ourselves. So the square root of 5 times the square root of 5. So let's just kind of do this right here. The square root of 5 times the square root of 5 is the square root of 25, which is just 5. So I'm going to put the square root of 25 right now. All right, so that's my first. The outer, a positive times a negative. Always look at what you have. A positive times a negative is going to be a negative. And notice I have the square root of 5 times the square root of 2, which is going to be the square root of 10. So minus square root of 10. The inner, again, a negative times a positive is a negative. And I have the same thing. The square root of 2 times the square root of 5 is the square root of 10. And then the last, a negative times a negative is a positive. Always look at this. A negative times a negative is a positive, so be careful with your signs. And we have the square root of 2 times the square root of 2, which is the square root of 4, which is just 2. Okay? Let me put the square root of 4. Since I left it as square root of 5, I'm going to leave this as square root of 4. Now let's simplify this. This is a 5. This right here, I can combine these because both terms are the square root of 10s. This is a negative 1. This is a negative 1. So I have negative 2 of them. So that's minus 2 square root of 10, and then plus, and then the square root of 4 is 2. And then combining like terms, I can combine the constants. 5 and 2 is 7, so I get 7 minus 2 square root of 10. Okay? All right, now, before we go any further, remember, think about this for a moment. If I have the square root of 11 times the square root of 11, I can multiply it out, 11 times 11, and notice I will get a perfect square, which is 121. I'll get a perfect square. And notice why you're going to get a perfect square, because the radicands are the same. So basically you're saying that's going to be the square root of 11 squared. And remember, when we get our perfect squares, we're taking a whole number and squaring it. So this is going to be a perfect square, and you're basically going to be left with 11. So that's going to be 11. So just keep in mind, if you have the square root of, let's say, 102 times the square root of 102, then it's just 102. Because the square root of 102 times the square root of 102 means the square root of 102 squared. 102 times 102 is 102 squared. And when you square a whole number, whatever that product is, 102 times itself, that's going to be a perfect square. And the square root of that's going to just be this number right here, 102. Okay? All right, so just keep that in mind as you go through this. Now, if you didn't see it, you can go ahead and say the square root of 25, but you have to simplify. That's 5. You can say the square root of 4, but you have to simplify it. That's just 2. All right, number 3. All right, suppose we had 5 times the square root of 6 minus 3. So again, I'm going to use a distributive property. Now that's not the square root of 5. That's just 5. So I'm going to get 5 times the square root of 6 is 5 square root of 6 minus, and then 5 times a negative 3 is a negative 15. And that's all you can do. Those are not like terms because this has a square root of 6, this has not. So this is your answer. Number 4. You have 3 square root of x minus 4 times 2 square root of x plus 5. So again, I'm multiplying two binomials. So let's use the FOIL method, and let's do step by step. Okay, so look at what I have. I have 3 square root of x times 2 square root of x. So think about what we just talked about right here. The square root of 11 times the square root of 11 is just 11. The square root of 102 times the square root of 102 is just 102. The square root of 2 times the square root of 2 is just 2. The square root of 5 times the square root of 5 is just 5. Okay? So 3 times 2 is 6. The square root of x and the square root of x is just x. Now, if you didn't see it like what we just talked about, then you're going to say the square root of x and the square root of x is the square root of x squared, and the square root of x squared is just x. Okay, so the square root and the square root undo each other. You're just left with x. All right, but keep all that in mind that we just talked about. So the first is going to end up being 6x. 6x. All right, now the outer. A positive times a positive is a positive. All right, let's see what we have. We have 3 square root of x. Write it out. 3 square root of x times a 5. All right, well, 3 times 5 is 15, so you just get 15 square root of x. That's what this is, 15 square root of x. All right, now the inner. A negative times a positive is a negative. All right, so I have 4 times 2 square root of x, and 4 times 2 is 8, so I get 8 square root of x. And then the last, a negative 4 times a positive 5 is a negative 20. Okay, now combining like terms, let's see. I have 6x. I can't combine with anything else. I can combine these because both of these terms have square root of x. And 15 subtract 8 is going to be, what, 7? So it'll be 7x, 7 square root of x, and minus 20. And there are no other like terms, so there's your answer. This is the answer. All right, number 5, you have the square root of 13 times the square root of 13 plus x square root of 26. So the square root of 13 times this binomial. So if I distribute, you're going to get the square root of 13 times the square root of 13 plus x square root of 26 times the square root of 13. So square root of We multiply each of these by the square root of 13. So square root of 13, square root of 13, plus x square root of 26 and square root of 13. Okay? Now this one's easy. Based on what we just talked about, the square root of 13, square root of 13 is just 13. Now if you want to do it the long way, 13 times 13 is 169. The square root of 169 is 13. Alright, now let's look at this one right here. What you can do is this. You can go ahead and multiply these two together. So the square root of 26 times the square root of 13, 26 times 13 is going to be 338. Okay? Now, the problem with this is this. It's a little bit harder for you to determine what perfect square goes into 338 because that number is probably bigger than you can think of with regards to perfect squares. So what I would do is I would go back to this one right here. See that 26? So let me go ahead and rewrite it here. Square root of 26, square root of 13. Look at that 26. 26 is 2 times 13. Okay? And then this is already square root of 13. So this right here becomes 2 square root of 13, square root of 13. And then this right here is just 13. So I get 2 times 13, which is 26. Oops, I'm sorry. I kind of messed that up. The square root of 2, I'm sorry. Square root of 2, I put a 2 here. Messed up. Okay. So that's square root of 2 times the square root of 13, square root of 13, and square root of 13 is 13. So you get 13 square root of 2. So that's what this is. Sorry. So this becomes 13 plus x times 13 square root of 2. And we prefer to write the answer with the x between the whole number and the square root, just like with the imaginary units, imaginary numbers. So that's 13 plus 13, x square root of 2. All right. So notice what I did to kind of figure this out. It is much more difficult to determine what perfect square goes into 138. So use the fact. Use this right here. Rewrite this to make it simple in yourself. So the square root of 26 is 2 times 13. And I can write the square root of 2 times 13 as the square root of 2 times the square root of 13. And then this square root of 13 times this square root of 13 is just 13. So I get 13 square root of 2. All right? Okay, and then let's look at one more. This will be number 6. All right, number 6. You have 6 square root of 5 plus the square root of 2 times the square root of 5 minus 3 square root of 2. So 6 square root of 5 plus the square root of 2 times the square root of 5 minus 3 square root of 2. All right, so again, you have two binomials, so you're going to FOIL. So go off to the side and figure that out. So 6 square root of 5 times the square root of 5. Remember we just talked about the square root of 5 times the square root of 5 is just 5. It's the square root of 25, and the square root of 25 is 5. So make things easy to yourself. That's just 5. So I get 30. Now the outer. First of all, a positive times a negative is a negative. All right, now let's look at what we have here. We have 6 square root of 5 times 3 square root of 2. 6 square root of 5 times 3 square root of 2. So 6 times 3 is 18. And then the square root of 5 times the square root of 2. Remember when you multiply radicals, when you multiply square roots, you just multiply the radicands together. So it'll be the square root of 5 times 2, which is 10. So that's what goes here. So that's 18 square root of 10. Over here, a positive times a positive is a positive. And I have the square root of 2 times the square root of 5. Well, the square root of 2 to the square root of 5 is the square root of 10. And then the last here, a positive times a negative is a negative. All right, let's see what we get. We get the square root of 2 times 3 square root of 2. All right, look at this. The square root of 2 times the square root of 2 is the square root of 4, which is just 2. So I get 2 times 3, which is 6. Let's get minus 6. All right, now combine like terms. 30 subtract 6 is a 24. So 30 subtract 6 is 24. A negative, now these I can combine because they both have square root of 10s. A negative 18 and a positive 1 is a negative 17. So I get minus 17 square root of 10. And I can't combine them because this does not have a square root of 10 in it. So that's the answer. All right, so that takes care of part 3.